Hi, today we're going to talk about the experiment we did to find the distance from our school to the Nation Tower, even though we can't leave the school. By the end of this video, you'll be able to use trigonometry to find the distance of objects you can't measure directly.
We need to find the distance, but we don't know the height of the Nation Tower, so we can't use tangent like we did for the flagpole.
Law of sines. It can be used to find missing parts of the triangles, and it can be used to solve a triangle.
Sine of A would be divided by segment A, which is equal to sine B divided by segment B and sine C divided by segment C.
We use this to measure the distance from ICS to Nation Tower. So we need two angles to left and right. So first you will go to left side, choose a specific spot, measure the angle, and then you will go to the right side, choose a specific point, and measure the angle from there. Through this, we have to also measure the distance, and then we can find the distance from the Nation Tower to ICS.
To find the distance from our school to the Nation Tower, we had to choose two spots within our school gate, and the distance from those two spots is 30 meters. The next thing that we have to do is to measure the angle from each spot by using the same reference point. So in this case, we're using the yellow part on the top of the building. The first angle we got was 69 and the second angle we got was 93. So to review the information, the distance between the 2 points that we chose was 30 meters, and the two angles that we got was 69 degrees and 93 degrees. We all know that inside a triangle, all the angles add up to 180 degrees. So to find the third missing angle, what we can do is 180 minus 93 minus 69, and we will get 18, which is the missing angle. Now that we know all of the angles, we can use the law of sine to find x, but in this case, x can be on both top and bottom. It doesn't really matter because it's both the distance within the gate of our school to the Nation Tower, so we'll just use the shorter one. So now just plug in the information into the law of sine equation, which give us sine 18 over 30 equals sine 69 over x, which x then equals 90.63 meters.
You may have noticed that our measurements weren't that accurate. It's because our instruments here that we use aren't very high quality, and that we don't have the amount of skill and the amount of materials and equipment to make a professional measurement.
As you can see, the materials we used are not very accurate. Like straw and stupid little pen and eraser and straw, it's not very useful. And then when you try to use it, it's not very accurate because it all depends on your point of view.
The second piece of equipment was also similar. They were also made of cardboard, straw, and a lot of tape. And it also relies heavily on the student's perspective. And especially this one was used to measure the distance to the Nation Tower, which was extremely far away. So when you looked at it, we had very varying measurements in the process.
Pro this, man.